Welcome to the Algo Reviews. In this video, we're going to be looking at how to represent organic molecules. Organic molecules can be represented as bond lines, sometimes also referred to as line drawings or skeleton. They can also be represented as Lewis structures where all the atoms and the bonds in the structure are basically shown, or can be represented as a condensed structure. Let's take an example and look at how each one of them is drawn. In a bond line, the carbons of the structure are not drawn out. The C, which is the atom, is usually omitted, and in place of it, you only have a line drawn. Remember, each point on this line represents a carbon, and all hydrogens attached to carbon are usually omitted. But you have to bear in mind that these carbons have imaginary hydrogens attached to them. The only time that you see a hydrogen connected to a carbon showing is when you have a carbonyl. When you have something like this, then you have to show that hydrogen. Now, another rule is that when you have a hydrogen that is connected to any non-carbon, such as nitrogen, oxygen, sulfur, then you have to show that particular hydrogen. In Lewis structures, you have to show every bond and every atom in the structure. So let's look at the structure of methane. So methane is one carbon connected to 4 hydrogens. So we're going to show every hydrogen and the carbon in this structure. In the condensed structure form, the structure of methane will be represented by just the atoms and how many of them that forms the structure. So there's only one carbon in the structure of methane and 4 hydrogens, so that is made as a subscript. Now, we're going to take a dive into each one of these and illustrate it with more examples. So how do you draw bond lines when you're given a condensed structure? Let's begin this with an example such as pentane. So pentane has 5 bonds and it has a condensed structure of CH3, CH2, 3CH3. Now, how would you represent this one as a bond line? You have to, first of all, look at it as a Lewis structure. And in order to do that, you have to draw out all the carbons in the structure and also put all the hydrogens on each one of them. So that way we will be able to identify how the atoms are connected to each other. So with that out of the way, we have to draw our bond lines. Now, to represent the bond lines, you keep in mind your numbering of these carbons. So carbon number 1, 2, 3, 4, and 5. You have to draw your bond lines as a zigzag. So the first carbon is the point of the line. So this bond line represents carbon number 1 and carbon number 2. And then you go on in a zigzag fashion. So until you get to carbon number 5. So it's simple as carbon number 1, 2, 3, 4, and 5. In a second example, we're going to look at how we're going to draw the bond line of this condensed structure. The condensed structure is CH3, CONH, Now, how would you represent this as a bond line? First of all, we have to identify this as a Lewis structure. And every carbon in this structure, again, will have to be labeled. So this will be carbon number 1, number 2, and carbon number 3. So to make it easy, we're going to draw all the carbons and the atoms, the heteroatoms in the structure. So that's carbon number 2 connected to this nitrogen. And this carbon is connected to this oxygen. And that nitrogen is connected to that carbon number 3. So you put all the bonds in place, making sure that carbon has 4 bonds, oxygen has 2, and nitrogen has 3. So I'm making sure that every carbon has 4 bonds. So carbon number 3, as you can see, has all the 3 bonds. Carbon number 1 has all the 3 bonds. However, carbon number 2 is connected to oxygen and nitrogen. And remember, this nitrogen has a hydrogen attached to it as well. This carbon right here, carbon number 2, still needs 1 more bond. And as we all know, oxygen needs 2 bonds. So you can have a double bond between that carbon number 2 and the oxygen. Now with this out of the way, you can easily do the bond line by just starting off with carbon number 1 as a point of contact and drawing to carbon number 2. And we know carbon number 2 is connected to an oxygen by a double bond, and then it's also connected to a nitrogen, but then you have to show the hydrogen of this nitrogen, which is connected to another carbon, and of course it's a terminal carbon, and therefore we don't show anything. So this will be the bond line representation of this structure in the condensed form. So we're going to look at another example 3. The condensed structure is giving us O into bracket CH2, CH3, CH, CH3. Looking at this structure, how would you be able to represent it as a bond line? It's very simple. All you need to do is to draw out the Lewis structure. So you have 3 carbons making up these methylene groups, and that's what you see here. So they all have these hydrogens attached to them, and it's in a chain. That's why we have them as a subscript 3. Now the last carbon on this is attached to an oxygen, and then the last carbon on this chain of 3 methylene groups is attached to a carbon that has 1 hydrogen attached to it, and also attached to a carbon, of course, a methyl group that has 3 hydrogens attached to it. Now this carbon it has a missing bond. It doesn't have the bond completed. It needs 4 bonds, and of course this oxygen has 1 missing bond as well. So what we can see is that it's actually a cyclic ring that has these two, this oxygen and that carbon number 4 connected to each other. So again, as a practice, you always try and number your carbons. So you have 4 carbons in here, and the 5th carbon is this methyl group. So because it's a ring, and you can count the size of the ring by looking at how many atoms make up the ring. So you have 1, 2, 3, 4, 5. So this is a 5-member ring that looks like that. So you will see that this is carbon number 1, carbon number 2, carbon number 3, and carbon number 4. But interestingly, on carbon number 4, you have a methyl group. Okay, so this is going to be the bond line representation for this condensed structure. Now let's take an example 4 and see how a condensed structure that looks like CH3, CH, CH, N into bracket CH3, CH2, CH3 will look like. This is a little bit complicated, but let's follow the same rules and we'll be able to draw the bond lines. So again, you're going to number these carbons so that we can identify which one we're dealing with. So this carbon number 1, 2, 3, 4, 5, and 6. Now before we go on, one thing I should stress is that whenever you see any group that is in a parenthesis, sometimes especially methyl groups, hydroxyl groups, or what we call substituents, it basically tells you that that particular group is born on that carbon next to it. So let's take a look at this. Now, carbon number 1 has all the hydrogens that it needs. It's connected to carbon number 2 that has only 1 hydrogen. Then carbon number 2 is connected to carbon number 3 that only has 1 hydrogen as well. Now, carbon number 3 is connected to a nitrogen. That, as I mentioned, has a methyl group attached to it. So it has a CH3 group attached to it because that is a substituent on that particular nitrogen. Now, this nitrogen is directly connected to a carbon that has 2 hydrogens. And of course, that is eventually connected to carbon number 6 that has 3 hydrogens. So again, we will have to come back to some of the carbons or atoms that don't have the rules satisfied. We say carbon has to have 4, nitrogen 3, oxygen 2. So in this case, we're going to look at these carbons right here. These 2 carbons kind of only have 3 bonds each. So in order to satisfy that bond requirement, we're going to add 1 bond in between them. So then this becomes a double bond that we have to consider. everything else looks good. So in order to draw the bond line structure, all that we need is to be able to recognize these atoms. So atom number 1 is a carbon connected to carbon number 2, which is connected to carbon number 3 by a double bond. And this double bond is connected to nitrogen, which has a methyl group. And this is connected to a CH2 group and then a CH3 group. So every point here represents a carbon with hydrogens, but then it's not shown. And of course, this carbon right here has a hydrogen, that one has a hydrogen, but because they are carbons, we do not show them. So let's take the last example, 5, which has a very complicated condensed structure, and see how we can draw the bond line from this. We're going to follow the same rules we've been doing so far, which is we're going to draw the Lewis structure. And before we do that, as a rule, you try to number all the carbons. So I have 1, 2, 3, 4, 5, and of course I have about 4 more carbons here, but I'm not going to number those. Now let's look at the Lewis structure. So with the Lewis structure, we can look at the carbons from 1 all the way to 5 and see what is missing. So we can label this as carbon number 1, 2, 3, 4, and 5. And we know that a carbon number 1 has all the hydrogens attached to it. So that has all the 4 bonds, and carbon number 2 has 2 hydrogens attached to it. Carbon number 3, on the other hand, has a CH3 group attached to it. And of course, you can draw this out as hydrogens with bonds. Carbon number 4 has 1 hydrogen attached to it, and carbon number 5 has a hydrogen attached to it. And also it has all these methylene groups, about 4 of them. Okay, so all of them have the hydrogens attached as well. Now, looking at this, you realize that the certain carbons don't have all the 4 bonds. And we will find out what is really going on. So let's take a dive and look at some of the carbons. So carbon number 3 and carbon number 4, both of them don't have a bond. So what we can do is introduce a double bond between them, and that will make them have 4 bonds. Now, when it comes to carbon number 5, which already has all the atoms accounted for, but then it's missing 1 bond, and carbon, the last methylene group of this chain of methylene groups has no bond or has no atom bonded to. So we can imagine that these two could be attached to each other through a ring, right? So because it's a cyclic structure, we will have to find out what kind of cyclic structure it is. So it's made up of 1, 2, 3, 4, 5 atoms. So that will be a 5-member ring. And that will be attached to the rest of the molecule. So let's see how the bond structure will look like. So let's begin this off with carbon number 1. The point of contact is right here, and this is carbon number 2. Carbon number 2 is connected to carbon number 3. That is double bonded to carbon number 4. And it's again, carbon number 3 has a methyl group right here. So we know that there's a methyl group there. Carbon number 4 is connected to carbon number 5, which in turn is connected or is part of a 5-member ring. And therefore we will draw that out. So if you watch closely, you realize that this is carbon number 5 right here that is in the ring. And this is going to be carbon number 4. And that is carbon number 3, carbon number 2, and carbon number 1. And the rest of the methylene group, the 4 methylene groups, is found in this ring.